it is asked that there is a message signal of frequency 20 kilohertz and the peak voltage is 20 volts. That is peak voltage of message signal, if I denote it by capital M, this is equal to 20 volts, and it is used to modulate a carrier signal of frequency 2 megahertz and peak voltage of 40 volts. That is peak voltage of carrier amplitude that is equal to 40 volts. So the modulation index will be M by A, that is 20 by 40, this is equal to 0.5. So it is asked find the modulation index, and also it is asked find the side bands produced. The side band produced are frequency of the carrier wave plus or minus frequency of the signal wave. Now the side bands is frequency of the carrier wave is 2 megahertz plus or minus this is 20 kilohertz, which is frequency of this signal. Now let us try to write it in terms of the same unit. 2 plus minus 0.02 into 10 to the power 6 hertz we can write, or this much megahertz, that is it is 1.98 megahertz and 2.02 megahertz. These are the side bands. And now it is also asked draw the corresponding frequency spectrum for the amplitude modulated signal. Now for the amplitude modulated signal, the minimum amplitude will be 40 volts minus 20 volts, that is 20, and the maximum will be 60. Similarly, on the other side also it is minus 20 and minus 60. So in between these two, it will oscillate. Therefore, we can draw a rough sketch like this. Similarly, on the other side also we can draw a rough sketch like this, and the oscillations are taking place in between these two, as it can be shown drawing figures of this pattern. This is the corresponding frequency spectrum of the amplitude modulated signal.